I think we're live. Hi, everyone. Welcome to the Big AI and CAD webinar. Let me introduce myself as well as my colleague. My name is Darren Henry. I'm one of the executives here at PTC, working at the Onshape business unit. And joining me also is Greg Brown. Greg Brown leads our product team at Onshape. You want to wave, Greg? We'll talk to Greg in a second. I want to go through, we have a lot of people attending this webinar. We appreciate that. I want to go through the agenda very quickly. We're going to keep it simple today because we have some really exciting things to show you. We're going to talk about the intersection between AI and CAD, and we're going to review with examples the common way that AI is integrating into CAD. We'll explain the challenges related to text to CAD. I think this is a topic on a lot of people's minds. We're seeing a lot of examples on social media about text to CAD. We'll give you one vendor's perspective on text to CAD, and then we're going to introduce something new, text to code to CAD. This is something very unique to Onshape, but we feel it's the most groundbreaking capability with AI. We're getting incredible results. We're going to show you real examples live of that technology. And then we're going to suggest how to get started, because this technology is something that we're putting in the hands of all Onshape users, whether you're a student teacher, whether you're on the hobbyist plan, or whether you're a commercial customer. So you'll want to stick around and make sure that you understand how to get started, because you can do it today. We're going to leave time for questions and answers as well. So if you have questions, you can put them in the comments. I would say if you want us to answer them, maybe save them for the end of the event, and so we'll see them. But by all means, add things to the comments. We're going to try to answer them as we go along. You know, right now, there are four categories, four common ways that AI is integrating into CAD. And the first one has been around, you know, for about 2 years, or at least over 18 months. And that's using AI as an advisor. This is where we leverage sort of the natural language aspect of an LLM, and you can type in a question, and it'll be an assistant that answers the questions. It'll explain workflows and provide guidance. Onshape was one of the first CAD vendors to actually introduce that. We have a product or an offering called AI Advisor. You can access it right within our interface. And in this example, it's a screenshot, but basically the person's asking, how do you create an if-then statement between two dimensions? Something that's not commonly done. You might get rusty and forget the actual format, but you ask that simple question, it retrieves that data. And the more specific your question is, the more likely you'll be able to just cut and paste that information right into the CAD system and get your work done. What's really nice about this is that it's been trained on all of our trusted content, whether it be documentation, our webinars, our tech tips. So you really have an assistant that sits with you 24/7. If you haven't used it, we suggest you do. Extremely popular. And in fact, we've seen tech support calls per user go down since we introduced this. We're talking about it's being used where we see thousands of queries a day. Really, in the most popular business hours, we're seeing multiple queries a second. So it's a very, very popular tool. One thing I want to point out is the cloud native architecture of Onshape actually has advantages whenever we integrate with CAD. And this is one with AI. And this is one that's that sort of fits that mold, because we update the content every 3 weeks when we update each release of Onshape. And if you're not familiar with a cloud application like Onshape, the minute we update functionality and update the resources to get help on that functionality, everyone on the planet is on that latest version. If you can imagine, if you have an installed based CAD system with an online tool helping you, or an AI tool that's helping advise you, you might get a version mismatch. You might type a question and the AIs knows the latest release, but you're on an older release. So that cloud architecture gives you distinct advantages, and I'll mention those as we go through the different categories. But using AI as an advisor where you can have a natural language prompt and it assists you is just one way that AI is helping CAD. Another way is discrete toolkits. So we're seeing discrete tools that are purpose-built to do a specific task. We're seeing those appear in a lot of different CAD vendors' applications. And we're no different. We have a number of these. You might be familiar with Onshape's replicate annotation. So this is using machine learning to look at a view, and if you choose to select that view and you want to replicate its annotations, you can pick a similar view, maybe in a completely different drawing, and it will use its machine learning algorithms to attach those annotations correctly. So if you're doing any type of family of parts, this is an extremely powerful capability. It's just one example of leveraging AI or machine learning to build a purpose-built tool that will save you a tremendous amount of time. Now, you're going to see a lot of these types of discrete tool sets emerge, and some will fit your workflow perfectly, others may not, but the purpose of this is to actually save you time and work within the confines of the CAD system. We have another one coming out. It's actually in early visibility, but this is quite exciting because it's using an AI model. It's using a diffusion-based image creation to do a quick rendering. And the beauty of this is it works right inside Onshape. It takes the orientation of your model with a prompt that you give it, and it can actually provide a quick rendering. In this image, we're actually asking that the robot arm be placed on an engineer technician's workbench surrounded by other test equipment, and you can see how well that happens. So in many cases, we feel that ray tracing may be overkill for some of the applications you want. Maybe you want quick rendering, maybe you'd like to see your product in a sort of interesting environment. Well, quick render suits that bill. And again, it's a purpose-built AI tool that does a specific task. This one will be released through our Onshape Labs program. We'll talk a little bit about that, but right now it's in early visibility with some customers. We plan to put it in the hands of all of our Onshape customers in the near future. A third way that AI is being integrated into CAD is through natural language agents. We've actually shown a number of proof of concepts at a lot of different events, but these would work in product similar to Onshape AI Advisor, but they have the added benefit of gaining context to your work, and they can actually execute tasks. I have an example to show you of an agent. So what will happen here is we're typing in a question, asking it, hey, if we change the fencing of this trailer from steel to aluminum, how much weight will we save? And the agent actually understands the model. It extracts the weight of the different fence components. It swaps the material for aluminum, and actually in this case, it can save over 500 pounds. So you can see that these types of agents will work inside Onshape, have access to your data and get context, and they can actually provide you important insight. They can actually do tasks, or they can be stacked to do multiple tasks. How it works is we envision there'll be multiple agents, and when you ask a question, it will first go to an orchestration agent, which will then invoke the right agents. It's important to point out, though, that this has to be something that you have control of. And in our vision, you actually invite the agents to work on your projects, much as you would a teammate. So you have control over the permissions you give it. The task can be assigned, and actually multiple tasks can be assigned in natural language. And what's really important is that you want to be able to have the agents learn about your information, but keep that information private to either you or your company. And that's something that we're working on. The other thing that's nice about dealing with a database-based system like Onshape is that we track all activity, so you'll be able to see what the agents actually do, and of course, be able to restore before the agents actually did those executions if you have to go back in time. So the key here is, as you think about agents working inside your CAD system, I think what you need to consider is, do you have control of those agents? Is everything tracked? Is it clear what the AI agent did versus a human? And is it something that you can literally invite them to and then revoke access to at a later date? All those are things that Onshape is working on. You'll see agents in the product later this year. We have a number of proof of concepts. We've shown a number of them that does batch export. It queries parts based off metadata like materials. You can ask it, how would I make the performance better on these models? And it will look at that and give you best practices. We've seen automatic drawing creation. I know that's a topic that a lot of people are asking. It'll be addressed through AI agents within Onshape. And we've also seen goal seeking, where you can actually give it a goal and it will change the parameters and try to converge on that goal. All those examples we've shown at different webinars. There was one called PTC AI in Focus. If you're interested in that, you might want to watch that. But this is something we are working on and that you'll see in product very shortly. And then the last category is text to CAD. And as I mentioned earlier, this is one that's getting a lot of hype. There's a lot of social media where people are saying, hey, I asked Claude to create a hinge bracket or a Raspberry Pi case, and you see that it's working on utilizing CAD and building these geometries. Unfortunately, we think if you double click into some of these results, it's going to you're going to come to the same conclusion that we do, that it's just not ready for prime time. Here's what we're learning. We're seeing that most of the successful examples of connecting an LLM to a CAD application is yielding products that are of low complexity, models that are low complexity and not easily editable. But more importantly, we're finding that it's lacking understanding the geometric relationships. If it had to create a sketch on a surface, in many cases it's creating a construction plane, not sketching on those surfaces. It seems to be lacking the understanding of the sketch constraints, the spatial interpretation, feature dependencies, as well as what's related. If you said, find me all the adjacent faces to a fillet, LLMs struggle to understand that sort of spatial recognition. And we feel that this is a miss for what the market wants. The market wants AI to understand their domain expertise, build models with design intent that are robust and can easily be edited by a human. To illustrate this point, we can ask an LLM to make a washer model, and it will do that. But if you try to edit that washer, you might find that the sketches lack the intelligence, the constraints. It doesn't know that the two circles are concentric. It may not know to apply the dimensions. That's a rather simple example, but it illustrates one of the challenges is that LLMs don't necessarily understand sketch constraints. In the prompt that actually went rather viral was make a Raspberry Pi case. What we found was that the rectangular shape that it made, if you tried to change the dimensions, the sketch entities didn't even know they should be concentric and didn't even or not concentric, coincident at the corners, or parallel and horizontal. So if you tried to edit it, you'd have to go in and manually do quite a bit of work. And I think what everyone on this call understands is that just sketch constraints is just one aspect of the problem, but a washer would require 4 constraints, a rectangular base, probably about 12 constraints. And I wanted to point this out because I think most people have sketches that are more complex than a simple box. This is a sprocket tooth profile. And if you were to build that correctly, you're building dozens of construction geometry, as well as putting in about 75 geometric constraints just to capture design intent. And we feel like most people have complexity between the sprocket tooth and the rectangular base. And this is something that would be a goal for AI to learn, But right now, the current state of just having an LLM connect to a CAD and building a part as you would, it just is lacking. What we do realize, though, is that AI is incredible at coding. So as we approach these problems, we think, boy, wouldn't it be great if we could code our way through all the different challenges? And it just so happens that Onshape has a very unique coding language that we put in from day one. And our intention was a coding language that would allow our human users to customize Onshape to suit their needs. It's different than a scripting language, like a macro scripting language, which may let you push certain buttons or execute certain CAD commands in a sequence. What Onshape Feature Script allows you to do is actually build new buttons, new CAD capabilities. And in this example that I'll try to show it with my mouse here. This is building a wavy spring. You can see that it actually built a single feature that captures this wavy spring. So we're building a new CAD command. What's great about this is Feature Script understands topology and the feature dependencies. It can query faces and edges and adjacent geometry. So it really understands, or can understand, all those spatial challenges that LLMs are faced with. It can easily regenerate features with design changes. So it's calculated much like an extrude or a fillet command, exactly like that. It's the same code that we use to build our features. And it really encapsulates engineering logic. So this is key. With Feature Script, you can capture the design intent. You can build advanced features with feature dependencies. And the end result is human editable with a little interface that comes along for the ride, much like you see here for the wavy spring. Now, the big breakthrough is that our teams at Onshape Labs have created an Onshape Feature Script MCP. And what this does is it allows the LLMs to actually code Feature Script, but not only code it, it will debug the code, write the custom feature, test it, run it within Onshape, look at the results, and iterate until it gets a result that it feels is appropriate, and then present those results to you. So with the LLM, you put in a prompt, it interprets the prompt, it will prototype the snippet, write the feature, debug it, run it until it gets a result, validate those results, and then delivers to you. And if you want to then further test it and edit it, you simply reprompt again. So it's quite an interesting approach, and we're going to show you firsthand how it works. But what's really interesting, the most interesting aspect about this, is it allows you to get a fifth powerful category of having AI work alongside your CAD, which is AI-driven customization. So not only will this build intelligent geometry, but it will actually allow you to extend the value of your CAD, actually tailor it to the needs of your processes or your products. And the other thing that's really exciting is it is available today through our Onshape Labs program. So that's my prelude. I think I set you up nicely, Greg. Let's let me pass the screen to you, and we can take a look at some of this capability.
Okay, we should be right now. Is that, you got the right thing?
Yes.
You can see my screen?
Yes.
Yeah, okay. So yeah, hi, my name's Greg Brown. I head the product group here. So I'm looking after the product management, the strategy, the roadmap and prioritization. And this obviously is, changing the game for ourselves and obviously the industry. Thanks, Darren, for that setup. There's a lot of nuggets that I'm going to delve into. But primarily, I want to take you through a series of use cases, all with the Onshape Feature Script MCP, to show you that it's not just about creation of geometry in a standalone way, although that is a very, very common, very, very powerful and useful thing. But the rest of the spectrum might include things like creating reusable code for your own other custom features, or creating a sophisticated feature which doesn't stand alone, but it manipulates other things all the way through some more code wrangling, which we'll talk about, to a sophisticated standalone application. And I did see a question in the chat that somebody did want to see this heat exchanger example. So let's start with the standalone geometry creation. And I've got a bunch of different examples here that we've created using the Onshape MCP with an LLM such as Claude Code or Copilot. And I think, before I go into them, there are different approaches to it, but they all have the same thing. Basically, a single capturing of requirements fed into the LLM will create a custom feature, which then can be reused and shared very, very easily. So let's have a look at this live. Now, I'll show you it in use, and then I'll explain how it happened. So I've got a feature. Now, along the top of the user interface of Onshape are the features that we create. And we use this feature script language ourselves. But of course, you can create custom features. And now, using the LLM and Onshape feature script MCP, you can create your own special features like this. So this is a garden hose thread creator using the ASME B1.20.7 standard. And the person who created this, and I think it was Darren actually, who created this feature, prompted the LLM to say, I want a feature that stands alone in Onshape that allows me to select a cylindrical, oh, it's already done, a cylindrical face in the model and cut the thread according to the standards and the options that are going to be provided. And the prompting process built out the feature with all of these different options in here. And now this feature exists in Onshape's model as a feature. You can do all the normal feature things to it. You can come back and edit it. You can suppress it. You can pattern it. You can do all of the things because it is a feature. This is the really important thing about feature script inside Onshape. I've got another example here, which is another really fun one. So I've got a bottle, and the feature that we're going to create here is called the liquid fill. So I select the container, in this case, the vase. I select a reference dimension, and then I tell it how much liquid I want to put in. So whether it's 1.75 liters, and it will work out the height of the liquid in there. Now, again, the prompting for this was all purely on the requirements and the intent. Like, I want you to be able to create a standalone feature in Onshape that detects the inside of the container, that detects the how much volume according to different criteria here. Maybe we want to do a percentage fill or a mass of a certain sort of a liquid. And then the MCP server is working in harmony with the LLM to create the code that creates this. Now, this becomes really, really, really powerful when you take some of the other Onshape capabilities and make them, again, work in harmony with them. In this case, I've created a liquid fill for the first 500 milliliters of this. And then I'm using a pattern and a feature pattern that says, well, let's do this for 500 milliliter or half liter increments. And now we can see we've created the gradation lines on the side of this bottle. Now, this is just using the feature that the LLM created and the MCP server created, but then using it in a normal Onshape workflow. And I can do things in a normal Onshape workflow, which is to go back and edit a sketch perhaps. And this is where it becomes really cool, because we have an interactive way to affect that. And we can see that the levels are automatically updating and regenerating, because this is a feature. It's not a macro that we've created. It's actually a real honest feature inside Onshape. Now, this was done in purely, again, from prompting and requirements. And that feature there is now usable, and I can put this into my saved feature list. I've got a lot of features that I've created in here, and I can add this liquid fill to that one. Now, the third example of this geometry creations genre is a common piece of equipment that you might be using, and it's a roller chain for a sprocket, right? For a roller chain. So again, the prompting was, I want you to create a standard roller chain sprocket using a certain standard, using from a catalog that can be looked up online. And I want you to add, all of the options that the catalog is providing. So whether it's a single strand or a double strand or a triple strand, or change the number of teeth. And all of this is a pure parametric model built and driven by the standards of this particular catalog that's being used online. Options such as building the keyway in, or a set screw affordance there as well. And then you can see how it's even got the nice cosmetic thread for the set screw in there as well. And there's some interesting annotations you can see on this. All of the geometry, all of the annotations, all of the lookups to the actual to the catalog were created by the AI in conjunction with the MCP, so that the MCP server could tell LLM how to create this, how to make the sketches constrained, how to make them parametric. And this has got an interesting thing too, is that those annotations weren't just showing dimensions, they were actually the MBD annotations. Now, of course, we added MBD in Onshape fairly recently, but this is a really, really powerful use of it, because the LLM is doing the heavy lift as part of the feature to automatically create these annotations. And you see that it works seamlessly, because if I add a default tolerance scheme to it, all of those numbers will automatically update if they're indeed a default tolerance. So that's a really, really quick example. A few different examples there. Now I'm going to go over to a Visual Studio Code example to show you how it might look when you're operating this. So on the right-hand side, I've got my chat, and in here I've got some code that's being generated by the chat. So I'm using Copilot, and I can choose what particular model I want to use, whether it's a heavyweight one or something lighter weight. And again, you have to be careful, just like you do with AI. And I started the chat saying, I want you to create kind of like a shrink wrapping feature that will take any model that I give you, and it will create an organic shaped shrink wrap around it. And so we went through a number of different options. Now, we all use AI differently, whether you're a pure programmer or a product manager like myself, or an executive or whoever, right? We all have different ways of approaching the chat. And my way is, I know a lot about feature script and I know how to program it. And I have but I have more ideas than I have fingers to be able to type that code. So using the AI and the MCP server has unlocked my own productivity insanely, because I can come up with a crazy idea and get a proof of concept in record time. So the crazy idea that I was happening here was that I could go to, bring up my model, that I could take any geometry, and if you've seen any films this year, you probably should see Project Hail Mary. It's a good film. And I wanted to create a feature that would take any object, including mesh like this, and encapsulate it in an environment just like Rocky would have wanted. Right? So it's an interesting feature because it finds the extents, and it's not a pure tessellation. It's actually doing something a little bit more organic and creative. And I built that into the prompt. Right? So I said, I don't want you to just do a bounding box and tessellate it. I want you to do something that looked like the film. And I used real human language to talk to the LLM to get to this point. All right. So what did we learn? We can go from ideas to proof of concepts within minutes. We can go outside of our own thinking and look at searches online to get references from catalogs and so on and so forth. The features that we generate, whether it was the garden thread or the sprocket here or the filling of the liquid, these are features in Onshape in all respects. They can be suppressed, edited, patterned, and all of those good things. And they can also manipulate properties such as material appearances and MBD annotations. Very important stuff. So moving on to a quick one here, and this is more of if you're more familiar with programming already in Onshape in PechaScript. What I found myself doing quite often is I was making a feature. Now, I built a feature a long time ago which would color code parts according to their volume or surface area or a number of different criteria. And what I found I wanted to do was the same thing in a slightly different feature or another feature and another feature, and that is to create some color spectrum. So I got the LLM in conjunction with the MCP server to create a reusable set of code, so like a library. And the MCP server's benefit here was that it knew how to insert and put code into a feature studio, which is what's inside this Onshape document. And secondarily, it knew how to refer to it. So when I do a different feature, I just say, use my library for this to implement a reusable set of code that has things like different color maps, or the ability to flip the scale from one end to the other, or to create a log scale instead of a linear scale. Now that code function block is just easily reusable. And I do this all the time now because, in my own custom features that I do still build by hand sometimes, I have a library of reusable things, which is very, 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 very valuable there. So it's a really good tip to get the LLM not just to work on one feature, but to work on stuff that you're going to need in the future, and then tell the AI to go and reuse those things rather than developing them from scratch each time. Which brings us to the next tier of sophisticated features. Now, sophisticated features don't just stand alone and create their own blob of geometry, but they interact with other things that you might give it in the form of a query. You might find that a particular CAD system has different ways of doing things, and you wish that could be done in Onshape as well. So here's your chance, right? With those requirements in mind, I went to my LLM, hooked it up to the MCP server, of course, and got it to build this blend corner feature. So the blend corner feature is a pretty common one in fairly high-end CAD, where you can choose different fillets that are coming together. And when they come together, instead of just sort of making a sharp transition like that, you can actually get it to do the blend. So this is an interesting blend in the corner there. And if I go into my diagnosis mode, oh, by the way, asking LLMs are so good at coding, they really appreciate it when you feed them information like, please create some diagnostics, or please create some timing markers, because you can come back to them and use them later. So this has got sophisticated things like the diagnostic mode, the manipulators. So the manipulators on this blend, I can even turn that into G2 curves so that it's a smoother transition. And this is working on surfaces as well as solid geometry. So if I finish that, there's my blend corner. Here's the challenge problem that I also set it to do things with a convex and concave shapes at the same time. You can see the blend corner in there. So this is a really sophisticated feature that I've added, and there's way more of that opportunity as well. So the other one on the screen here was a section surface, or a conic surfacing feature that I created, and this was a very long-running project. Now, some interesting takeaways from this was that if you have niche features that only you or your company deal with, it's a really good way to capture that. You can use this for deep algorithm development. If you especially go onto one of the heavy thinking models, or wind up those controls for heavy thinking, you can get it to really, really nut out some crazy algorithms in there. You can ask it, because again, it's so good about coding, you can ask it to optimize for performance or quality or robustness or readability. Those are really good prompts as well. In fact, I used the profiling information from some of the diagnostics, as well as the profiling information from Onshape, and fed that back and said, look, this is what the profiler is telling me. Can you go fix it? And it found ways to optimize functions or to use other built-in functions rather than some slower things. And the big hint from that is that once you're developing your muscles around this, you can capture it as a skill. Now, I'm not going to go into how skills work and in today, because that's its own lecture or presentation. But it's really, really, really powerful when it comes to pulling all these pieces together, so that next time you do something, it's actually going to be even faster. So level 4 is code wrangling. All right, so code wrangling is dealing with code that already exists and then making something out of it that is even more valuable than you thought it was going to be in the first place. So this piston model here was something that I built quite a few years ago, and you can see here there are about 60 features. It's pretty accurate. I actually reverse sort of measured it all with mics from my motorbike piston. So it's got a fair bit of information into it. It's got a lot of design intent into it. There's variables up here, and some of these variables are actually expressions. For things like the thickness of the top of the piston is based on some kind of equation in there. But it's 60 features. So now, the point is that when you do this, and when you've been doing this since forever in Onshape, we're actually creating the feature script behind the scenes. This is how Onshape works. I can show the code that we've been creating here, and this is not intended to be really human interactable. This is just showing you what all the code was that went into creating this beautiful piston. And you'll see here, there's a lot of really complicated stuff with sketch constraints. So as Darren was pointing out before, sketch constraints are hard. And also queries between things, they're hard, right? And that's what a lot of this is all about, is the queries and the sketch constraints. But LLMs are really good at handling code. So what I did is I copied all of that and then dropped it into my Visual Studio Code again, and then said to the Visual Studio Code, to the LLM, turn these 60 features represented by these 2,000 lines of code, turn that into a single feature. And that's what it did. So it actually, you can see here, it's even called it a parametric piston. It came up with a good name. I didn't come up with that name. And it tells me here what it did. And there was some special information that it left breadcrumbs for itself about how it's going to handle these queries. So that's really, really interesting information. And so the net effect of that is that now I have a single feature called parametric piston. Now, not everyone's going to need this, but perhaps you do a lot of these, and you want to reuse this, and you want to be able to replay this many, many times. So now you can see it's created all of this completely on its own, right? And it's taken my variables, which were features in Onshape, and it turned them into inputs in the user interface, right? And it represents that as a single feature in the tree. Now, the good thing with this, and you can say, oh, well, maybe you could have done this with Derive, and maybe you could have shared this. I want this as a single feature so that I can pattern it, so that I can do all sorts of other things. And the really, really powerful thing here that we need to point out is that it uses the platform of Onshape to really flex and extend. I can share this, and I can make it public. I'm not going to do it today, or maybe soon, but if I press this button here, all of that work that we've done now becomes publicly usable by every Onshape user in the world the minute or the instant that I press that blue button. Right. And I can unshare it as well, right? So that's an important thing. So, that is a real power of just, going to the next level of features that I'm going to be using in my day-to-day life. You can overlay these two things, by the way, on top of each other. They're absolutely pixel perfect. Now, there's a slightly different variation on that of code wrangling still. And rather than copying an entire part studio, which is what I did before, maybe I'm just going to copy some features. So if I look at the code, this is a little boss joint that's commonly used in various industries, and some people call it a Diablo. So we'll call it a Diablo today. And if I show you the code, I can say, I'm not worried about these first few features. I want you to copy from this feature down to this feature. All right. And you'll see over on the show code, this is just normal Onshape I'm running, by the way, at the moment. So I want to take those features. I could do a copy and then paste that into my Visual Studio Code and then chat using Opus 4.8, whatever, and say, I want you to turn this subset of features into some reusable feature so that when I come to, in future, I'm going to have a model, and I can just say, here's the feature, And it determined, this is the really cool bit, it determined that it needed an origin and a base surface. These were the only two queries it needed. And it worked that out from the code snippet that I gave it. That's kind of cool, makes sense, but it's also mind-blowing at the same time. So, you know, here I can put this feature in, and of course, now it's parametric. Of course, it retains its parameterization. And it's a feature. Again, we can copy it, we can pattern it, we can suppress it, we can do all of the featurey things to it. So that's the that's what I call code wrangling, for want of a better word. And there's a lot of stuff goes on behind the scenes for those queries, especially the queries that were dangling, for want of a better term. The queries were dangling when I took them out of their original context and put them somewhere else. So featureization of existing code, you can turn lots of features into a single feature, retaining the parametric benefits, and of course, then sharing that, just like any other custom feature, you know, is with a hallmark of the platform we're building on here. These things don't exist as scripts or macros on their own. They're a part of, you know, an Onshape ecosystem. Which brings us to the sophisticated applications. You know, the spectrum starting from standalone geometry creation extends all the way to, you know, sophisticated applications. So this is again using feature script in Part Studios, obviously, but it involves a lot more logic, a lot more decision making, and in some cases solvers. So I'm going to show you a couple of examples here because these are my favorite ones. So here is the chassis of a Formula SAE team. Shout out and thanks to the Olin team for that. What I have done, and by the way, these are examples that I've done for the purposes of this webinar. I'm not saying they're all what you need, but just to give you a sense of the scope and possibilities, right? And the hint there is that the scope and the possibilities are virtually endless, right? It's just your human creativity is really the key here as well. Anyway, I started chatting to my LLM and said, I want you to build an FEA server, and I want you to do beam analysis inside the Part Studio, because I want to give a first pass analysis for both static and modal for the beams that are represented by any curve or sketch entity that I give it. So that's what it did. It allows me to do static or modal analysis. You can set different material properties here. You've got a library of different section properties. You can load it up in different ways, including pre-tension. And I also told it that I wanted to do tension-only members, like cables. And then it came back to me and said, you know, that's going to involve a nonlinear solver. And I said, sure, go for it. So it went and did what it needed to do to pull together from the open source, from the community, from the, you know, many decades of this being done, and put together a real solver. So it's doing that here, and you can see actually the deformed shape. And I gave this one a lot of prompting because you might not know, but my background is with FEA and simulation. So I gave this a lot of prompting about what I wanted it to do, and it did all of the heavy lifting behind the scenes, including, and this is a foreshadowing the final example, it creates these really nice custom tables to summarize the information. Here it's got the total mass, this has got the first frequency, and by the way, I have verified this frequency against about 2 or 3 other well-known FEA, and you know, I'm not saying this is an FEA solution for everybody, but it's an incredible first pass tool. Right, so minds were blown, kind of, you know, I blew my own mind here in being able what I could do with this. And if you have a look at it here, this was saying taking 2 seconds to solve. So that's you know, again, I'm really hyper vigilant about how much regeneration time that I might be asking the model to do. So I got the LLM to talk and to think about the solvers that it was using, and it generated subspace solvers in place of a direct solver, you know, those sorts of things. Very good at that. Now, the final example here is the one people might have seen before, because our own professor, or Michael Flesch, has been really, really successful in generating this. So, shout out and props to Mike for all his hard work and persistence in getting this one. What it is, it's a shell and tube heat exchanger creation tool. So it creates, really, it's a system here. It's not just a part, it's a system of parts. And again, based on prompting, saying using standards, using these kinds of approaches, put together a feature which builds all of the stuff that you see on the right-hand side. So you can see there's just different choices for the class of heat exchanger, whether it's a 1-pass or 2-pass, what side, whether you want baffles and whether you want all sorts of ASME-based standards on this and that. And the really, really interesting thing is do a whole bunch of checks and design checks, such as the hydraulics or the thermal analysis there. And you can see here, this one particularly creates a lot of really, really interesting tables from the heat exchanger. And I've shown you the performance ones here. So it's actually giving you the readout on the Reynolds number in the shell versus the tube, what the heat loss is, what the intake versus exit temperatures are for the hot and the cold side. All of these things are being calculated as part of the feature. It's pretty incredible to see how much you can pack into here, because it does, again, involve solvers. It involves a lot of logic. It involves going outside to get these standards and bring them back together. And again, encapsulate that in a single feature, which can be shared, which can be reused. Now this feature is done. The results from it are deterministic, right? It's not vibe coding or vibe engineering the results each time. That's an important thing to know. And I saw in some of the questions people have been asking about, is it going to use tokens each time we use it? Is it going to come up with different results each time we use it? No, right? This is the LLM was involved in the creation of the initial feature, not on the subsequent rerunning of it. So I think that is some really important takeaways here before I hand back to you, Darren. And that is, you can do a lot of deep research and discovery and implementation of custom solvers, and really, really advanced stuff. Again, LLMs and coding LLMs are perfect for this kind of activity. The MCP server to Onshape's feature script just allows it to kind of close the loop and make the connection to building robust, run and successful Onshape models. All these tools work seamlessly with everything else in Onshape. For example, with the truss analysis tool for that chassis, I was using query variables to grab all of the frame segments so that I could then feed that into my feature. That's just a natural thing. Configuration works the same way. Just configure this feature just like you would configure any other Onshape feature. And the last big tip that I should have put in more bold information is that you can use the LLM to create documentation that other people will see. Maybe you're going to do a tech handover, or maybe you're just doing documentation, or maybe you want to understand all that happened. Ask the LLM to do that documentation for you, and include that, please, when you create your custom feature and publish it for the rest of the world to see. There you go, Darren.
Yeah, I think all those examples were great. Someone asked, how reliable are these features? Well, every demo that Greg showed you is live. Feature script, custom features have been used by many of our enterprise customers. So I think we have the confidence that they are robust and won't fail you, obviously, as we do it live. I just want to highlight a couple of things with this new approach, text to code to CAD, to make sure that there was a lot shown. So let me just make sure everybody picks up some key takeaways. Number one is the complexity of the geometry. I mean, what you saw was custom features, custom parts, like the sprocket components. You saw systems of parts, like the heat exchangers, and advanced capabilities where it's actually converging on solutions like your analysis, your beam analysis. We did capture design intent, and it is editable through the interface that actually is built by Onshape. So you actually saw, in fact, in the case of the sprocket, I mentioned how complex that tooth profile was. It captured it without problem, and you could change those the sizes and the number of teeth very easily. The other key, I think Greg actually discussed quite a bit, but once it is codified with a custom feature, the results are always deterministic. If you give the interface the same inputs, you'll always get the same outputs. And the beauty of that, obviously, is the efficient AI token usage, where you only go back to the LLM when you want to add functionality or correct any error that you might have found within the custom feature. A good example, when we were doing the sprocket, we actually uploaded PDFs for it to look at and size different sprockets, but the tooth taper was not defined in the information we provided the LLM. So we went back and forth a few times, consuming AI tokens to fix that tooth taper. And now that it is fixed, we have a sprocket generator that we feel is accurate. We're not spending LLM tokens anymore. There were a lot of questions about how to get started. Let's go to the next slide, and we'll show how to get started. So today, the FeatureScript MCP is available in the Onshape App Store. If you go to our homepage right now, onshape.com, the banner is actually a takeover about this new technology, and you can click on it. But you'll have to go to the App Store. First, I guess you need an Onshape account. So if you don't have an Onshape account, you'll need one. The good news there is we have a lot of different plans, and professionals can sign up for free for up to 6 months with the Discovery program. Then go to our App Store. You'll have to subscribe to the FeatureScript MCP, and there's some instructions there to add the MCP to your coding LLM. Now, we do say coding LLM, so you want to use a model that's good at coding. Internally, we do use, I use Opus. I've started doing this at 4.8, but I use the latest Opus build. You'll have to specify a transporting URL. The good news is if this is difficult for you, just ask your LLM how to connect an MCP, and it'll prompt you through that. And then you'll have to do some authentications. You'll probably have to click a URL and authenticate that it has access to your Onshape account. We're getting a lot of questions, Greg, so why don't we move ahead to the questions?
Yeah, okay.
One question that I did see is, you showed the end result, the features live. Why not show how you coded it live? I want to just tell you that we could do that, but it's actually not an exciting process. You'll actually talk to the LLM, and it will make sure it can connect to Onshape and start building code. But generally, it takes up to a half hour to generate something like the sprocket that you saw. I did a bushing. It actually took 36 minutes, and now it's a configurable bushing with many different sizes. But basically, you're watching it test and iterate through a console screen or a terminal, and it will tell you, how long it takes. Typically, the standard components that I've created, the bushings, the sprockets, those types of things, are done under an hour. More complex things like the fill command, that might take up to an hour before it gives you a result, and then you test it, you reprompt, and it might take another hour. So we could show it live. It's just not very exciting, and you'd be staring at a screen.
Yeah.
I'm actually seeing is, well, if you have questions, type them in. Another one that I think people recognize is we do expect an explosion of custom features to hit the market. Just internally, we've created dozens. Without me, I've created a ton without any coding experience. We do recognize we need a better way to manage and surface different custom features written in FeatureScript. So I saw that as a comment, and it is something that we're talking about and working on. Yeah, do you have costs for the AI gen? How much did the models take to make? So that's going to depend on which LLMs you're using and the plans that you utilize. But I can tell you that I started out with just a professional plan of Claude, and I was doing several projects without exceeding my, I think it was a $20 a month limit. I think the more aggressive you get, you're going to exceed those limits. And obviously, if you have concerns about keeping your data sequestered within an LLM, you're going to want to move to an enterprise plan.
Can I grab one here, Darren?
Yeah, please, Greg.
A question about, will there be AI integration with PCB design? Now, the interesting thing is that the MCP server that we've done is very specific. And then Darren showed you a roadmap of other MCP servers, things like metadata in Onshape and some of the other areas. But your LLM and the orchestration is above that level, and you can go outside of the Onshape kind of family, to get it to talk to other MCP servers as well. And in fact, I didn't get it ready for today, but I've been doing something with a PCB design MCP server. I won't say which one, but to prompt it to do two things at once: the MCAD design as well as the PCB design. So yeah, that is eminently possible, and we're using it right now internally for being able to use multiple MCP servers to do different things. Yeah, that's the huge superpower of this.
One says, which LLMs are you using and have you developed your own? So internally, we tend to test with, we use GitHub Copilot, and we use a lot of different models in there, but Codex is one that we use quite heavily. And then we also use Claude, and we tend to favor Opus, the latest Opus build as well. One thing that I did want to point out, if you're going to use this, I'd recommend start with a simple project, maybe something that you've built internally that you want to codify. And the LLM is good not only at understanding your natural language text prompts, but also if you upload PDF or images, it can understand that. And in many cases, when it does its first iteration and I have to tell it to do a change, I actually take screenshots and use that with the LLM to communicate. So, don't just stick to text prompting, use PDFs and images to help it along. Another thing that I don't know whether we communicated well, and I want to make sure we do, is that the beauty of our feature script MCP is that it actually records everything it does. So the more you use it, the better it is. And as Greg says, you can actually enhance that with skills as well. They're independent of our MCP. It would be something that the LLM utilizes. But what I've noticed is the more I do a project, so for example, an early project, I asked it to specify or give me a pull down to change the color of a part. And later projects, it actually added that capability automatically. So I asked it for maybe a certain component. It was actually the fill. I asked it for the liquid. When I did the bushing, it actually had a pull down for the bushing, and it actually extracted out the material as bronze and added that automatically. So the more you use it, the better it will get. And it's because it has a persistent memory that's unique to you and kept private to you, on utilizing the LLM.
Yeah, it's a really important one for the coding that I've done as well. Sometimes it's made a mistake and it called a variable box, and that's a very bad name to call a variable because it's a reserved word. And it learned very quickly that. So you can see in the memory, in the feature script notes, that is, again, like Darren said, unique to me and personal. It's not shared with everybody. Do not use these names for variables in future, or do not do these types of, it learns and it remembers, and it's very, very good at, being able to reuse lessons learned.
Yeah. So there's a question about, will this capability be available for our EDU plans? And yes, our intention is to, well, yes, you can get it today. It's not our intention, it's live. Any plan can actually have this. The barrier of entries here is get a good coding LLM, and then with your Onshape account, go ahead through the instructions that we talked about earlier. I think we're coming up on 1 minute. I'm just looking if there's any other questions. Somebody did ask, is feature script human readable? And the answer is yes. And we haven't talked about all the other great projects of the Onshape Labs team, but we did just come out with Code Complete. So it's sort of if you're doing human programming of feature script, it'll prompt you with autocomplete and those types of things and help you with some logic. So it is very much a human codable language, and we have tools to help you along with that. Okay, I think that's it. Sarah, we'll pass it over to you. Is it time to end?